Hi guys! So sa pagpapatuloy ng ating lecture about pressure in static fluid under the Fluid Mechanics course, we will be discussing now about manometer, which is a pressure measuring equipment. But before that, let us first discuss what is a barometer. Atmospheric pressure is measured by a device called a barometer. Thus, the atmospheric pressure is often referred to as barometric pressure. So since we are getting the atmospheric pressure here, the formula that we will be using is basically the same as what we have discussed in previous lessons natin. So our atmospheric pressure is equal to the density of the fluid, the acceleration due to gravity, times the height or the pressure head. So since na-discuss na natin to in earlier sections natin, so let us now try to answer this problem para lang ma-refresh tayo in its application. Determine the atmospheric pressure at a location where the barometric reading is 740 mm mercury and the gravitational acceleration is equal to 9.805 meters per second squared. Assume the temperature of mercury to be 10 degrees Celsius at which its density is 13,570 kg per cubic meters. Okay, so in here, ang mga given quantities natin is first we have our barometric reading which is the pressure head. And this is equal to 740 mm of mercury. Now, our acceleration due to gravity is also given at 9.805 meter per second squared. And then, at 10 degrees Celsius, the density of our mercury is equal to 13,570 kg per cubic meters. No? Okay, so i-apply na natin itong ating formula here and substitute this value. So we have the atmospheric pressure is equal to rho GH. Okay, so the atmospheric pressure is equal to the density of the mercury, okay, which is 13,570 kg per cubic meter, times the acceleration due to gravity, which is 9.805 meter per second squared, and then our pressure head, which is 740 mm mercury. So we don't need to mention the mercury here because we already considered that as type of our fluid here. But since this is in millimeter, we will convert this into meters now. So we have 1000 millimeters is equal to 1 meter. So what will be our unit here? Now we have millimeter, which will be cancelled out. We have here kilogram meter per second squared, which is Newton. And then we have meter in our numerator and cubic meter in denominator. Therefore, our unit will be Newton per square meter. No? And this is equal to Pascal. So, we can actually convert this into kilopascal by dividing this to 1000. So, let us do that. We have here 1000 Newton per meter squared is equal to 1 kilopascal. Okay? So, therefore, our unit here will be kilopascal. No? So, our atmospheric pressure is equal to 13,570 times 9.805 times 740 divided by 1000 and again divided by 1000 is equal to 98.5 kilopascal. And this is our final answer for this problem. Okay, so now let us go to our discussion about manometer. So, what is a manometer? A manometer is a tube, usually bent in a form of a U, containing a liquid of known specific gravity, the surface of which moves proportionally to changes of pressure. It is used to measure pressure. Okay, so meron tayo dito mga picture down to explain the types of manometer. So we have first an open type manometer. See, the open type manometer has an atmospheric surface in one leg and is capable of measuring gauge pressure. So this one is an open top manometer. So as you can see, we have an open leg on this side, no? So naka-open siya sa atmosphere. That is why it is called an open type manometer. Then another type is what we call the differential type manometer. Well, this type of manometer has no atmospheric surface and capable of measuring only the differences in pressure. So an open type manometer can measure the gauge pressure, no? While the differential manometer can only measure the pressure difference. And there is no open surface here. So this is an example of differential type manometer. So wala tayong naka-open na leg dito, no? And then we have a piezometer. A piezometer is an open type manometer, but this is the simplest form, no? It is a tube topped in a wall of a container for the purpose of measuring pressure. Okay, so this is an example of piezometer. So as you can see, naka-open yung ating tube in this part, no? And then nakakonekta lang siya sa ating container here. Okay, so now to have an idea, no, or in order to visualize kung ano ba yung itsura ng YouTube manometer, so we have here an example of YouTube manometer. And when we are solving for pressure using a manometer, we will be using this equation right here, no? So better to take note of this equation. So medyo familiar na tayo sa equation na to, no? Because in our previous lecture, pinag-usapan na natin ito, and we did a lot of sample problems using this equation, no? But now we will be applying this to a manometer. So let us start by answering this problem. A manometer is used to measure the pressure of a gas in a tank. The fluid used has a specific gravity of 0.85, and the manometer column height is 55 cm, as shown in figure 3-20. If the local atmospheric pressure is 96 kPa, determine the absolute pressure within the tank. So, ang pinapahanap sa atin is yung pressure within this tank. Okay? So, we have an atmospheric pressure here which is 96 kPa. Okay, so yung orange color natin here represents the fluid na nasa loob ng ating manometer, which is having a specific gravity of 85. Okay? And the height it produced is 55 cm. So, okay, so we are being asked to get the absolute pressure within the tank. Okay, so take note that ang pinahanap sa atin dito is absolute pressure. And we have learned from our previous lecture that the absolute pressure is equal to the atmospheric pressure plus the gauge pressure, diba? And our manometer is capable of measuring gauge pressure. As you can see here, we have here the pressure at this point, for example, which we could express in terms of the fluid which is above this point, right? So in that case, we have here the absolute pressure is equal to the atmospheric pressure plus rho GH, no, at this point. And as you can see, this equation right here is equal to what we have in here, diba? So basically, they are just the same. So let us now solve for the absolute pressure, which is equal to what is our atmospheric pressure. We have 96 kPa plus the density of our fluid. We have the specific gravity, which is 0.85, okay, times the density of water, which is 1000 kg per cubic meter, times our acceleration due to gravity, which is 9.81 meter per second squared, times our height, which is 55 centimeter, no? Now, let us convert this to meter, which is 100 centimeter equal to 1 meter. So, what will be our unit once again? So, as you can see guys, paulit-ulit natin ginagawa to para masanay tayo to make sure that our units are consistent, no? So we have centimeter, which will be cancelled out. And then we have here kilogram, meter per second squared, which is Newton. Then we have meter in our numerator and cubic meter in denominator. Therefore, our unit is in Newton per meter squared, which is also equal to Pascal. However, we are going to add this to our atmospheric pressure, which is already in kilopascal. Therefore, we have to convert our term here into kilopascal now. So we are going to divide this by 1000. So, okay, so let us do that. We have 1 kilopascal is equal to 1000 Newton per meter squared, or Pascal. So our answer here will be in kilopascal, and we are going to add this to our atmospheric pressure, which is also in kilopascal. So therefore, our absolute pressure is equal to 96 kilopascal plus 0.85 times 1000 times 9.81 times 55 divided by 100, and again divided by 1000, which is equal to 100.586 kilopascal. So this is our final answer for this problem. Well, just for our record, all of this is our gauge pressure. No? Okay, so if you calculate for that, you will know that our gauge pressure is equal to 4.586 kilopascal. Okay, but for this question, ang required sa atin is yung absolute pressure. That is why we have this answer. Bago tayo magpatuloy sa ating discussion, we would like to ask for your support by subscribing sa ating YouTube channel. Please click on the notification bell para lagi kayong updated sa mga videos na ipopost namin. Okay, so now let's go to the next question. And this question was taken from the Transport Processes and Unit Operations 3rd edition by Christy J. Ginkoplis. Okay, so we're going to consider problem 2.2-4. And the title of this problem is Measurement of Pressure. An open YouTube manometer similar to figure 2.2-4a, this is the figure right here, no? 2.2-4a, is being used to measure the absolute pressure PA in a vessel containing air. The pressure PB is atmospheric pressure, which is 754 mm mercury. The liquid in the manometer is water, having a density of 1000 kg per cubic meter. Assume that the density rho sub B is 1.3 kg per cubic meter and that the distance Z is very small. The reading R is 0.415 meter. Calculate PA in PSIA and kilopascal. So, dalawang answer ang kailangan nating makuha dito, no? The answer is already written here, but there is no solution. So, sasagutan na lang natin siya and compare kung makukuha ba natin itong answer na naandito, no? Okay, so moving on, tignan muna natin yung mga given natin, no? So, kinukuha natin yung ating PA, itong required sa atin. So, ang sabi dito, distance Z is very small. So we can see that the value of our Z on this particular problem is already negligible. So we can assume that this is approximately equal to 0. And then given ang ating PB, it is mentioned that it is atmospheric pressure, which is 754 mm mercury. Our pressure B is equal to 754 mm mercury. Now, the liquid in the manometer is water, having a density of 1000 kg per cubic meter. So, our fluid A here is water. And the density A is equal to 1000 kg per cubic meter. Assume that the density of B is equal to 1.3 kg per cubic meter. So, the density of B is equal to 1.3 kilogram per cubic meter. So, napakababa ng density niya, no, compared sa water because this is a gas and this is a liquid. Now, the reading R is 0.415 millimeters. So, our R in here is equal to 0.415 meters. Now, if you're going to check itong libro ng Transport Process and Unit Operation, this problem is actually tailored to apply yung equation 2.2-14 ng ating libro right here. No? And this equation states that PA minus PB is equal to R, density of A minus density of B times the acceleration due to gravity. So, this problem is actually prepared to apply this equation. No? But we will not just apply this equation on this video. No? We are going to show you kung paano natin nakuha ang equation na to and how are we going to apply that on this problem. Okay, so naintindihan natin sa mga previous lecture natin on pressures in static fluid that yung fluid natin will have the same pressure at any point on the same plane, di ba? So, for example, on this point, ang pressure natin dito is equal to pressure natin dito. Okay, as long as they are the same liquid, kapag pareho ang level nila, they are having the same pressure. And we learned that in our previous lecture, diba? So therefore, on this case, this is still the same liquid as this. So this 0.2 in here, the pressure in here is equal to the pressure in here, no? Dahil pareho lang silang water, no? Itong blue liquid natin dito is water. So, the pressure at this point and the pressure at this point is just equal, di ba? So, that means the pressure in 0.2 is equal to the pressure in 0.3, di ba? So, the pressure here is equal to the pressure here. Therefore, kung kukunin natin yung pressure on this point, we have to consider PA and what is inside this tube, okay, having this height. And also here, we are going to consider PB and the pressure generated because of this fluid and the water here. Diba? So first, let us get the pressure on point 2. No? So we have P2. So in here, to get the pressure in this point, we'll have PA plus the pressure generated on this area, okay, which is the density of B, because this is having the same liquid here, no? So we have density of B, okay, and then the acceleration due to gravity, and then ang ating height, okay, in which ang height natin dito is Z plus R, di ba? So I will just change itong R natin. Gagawin ko tong Z plus R. Okay? So, ito na yung ating pressure dito sa point 2. Now, we are going to take the pressure in point 3. And that is equal to the pressure in point 3, which is first we have PB plus the pressure generated by the fluid B here. So, we have the density of fluid B, acceleration due to gravity, and the height. In here, our height from here to here is equal to Z. Okay? So, I hope this is clear. Now, we're going to take the pressure from here to here. So, we'll have plus the density of water, because now our fluid is water. So, we have here the density of water, acceleration due to gravity, and our height of the water, which is equal to R. Okay, so I hope clear tayo dito, no? Okay, now we are told that the value of Z is very small, which I said we can already assume that this is almost equal to 0. No? Okay, so we'll have here our Z equal to 0 and our Z in here is equal to 0. Therefore, ang maiwan sa atin dito is pressure A plus the density of fluid B, G, and R. Okay, because the Z is already equal to 0. This is equal to the pressure B plus this is equal to 0 because our Z is equal to 0. No? So therefore, this is already equal to 0. So therefore, we have only this term. So we have density of water, acceleration due to gravity, and our R. So we are going to get the pressure A, no? So i-isolate na natin yung ating pressure A. So we have pressure A is equal to pressure B plus density of water G R minus density of fluid B, G, and R. Okay, now we can factor our G and R. So we have here plus, okay, G and R, density of water minus density of B. So if you check now, this is similar to equation 2.2-14 na pinapakita dito sa book na ating pinagkuhanan ng ating problem. No? Okay, so now let us solve our problem. We are going now to substitute the value. So we have pressure A is equal to, ano yung value ng ating PB? 754 millimeter mercury. So we have 754 millimeter mercury. Okay? However, itong mga makukuha natin dito na sagot will be expressed in kilopascal. Kasi our density is in kilogram per cubic meters. You know, our height is expressed in meters. So definitely, our value here will be in kilopascal. Therefore, we have to convert itong millimeter mercury natin into kilopascal. So we will multiply this into 101.325 kilopascal over 760 millimeter mercury. Okay, so okay na yung ating PB, no? Now we are going to add first our acceleration due to gravity, which is 9.81 meter per second squared, and then our R. Ang R natin given is 0.415 meters. So we have 0.415 meters. And then we will subtract itong density ng water into the density of our fluid, no? So what is the density of water? We have 1,000 kilogram per cubic meter minus yung density ng ating fluid, which is 1.3 kilogram per cubic meter. Okay, so guys, ilang beses na natin itong nagawa in our previous problem. So we know that our unit here will be in Pascal, no? Or Newton per square meter. So we are going to convert that into kilopascal. So we have 1 kilopascal over 1,000 Newton per meter squared. Okay, so this is now in kilopascal. So what is our answer here? We have pressure in A is equal to, well, 754 millimeter mercury times 101.325 kilopascal over 760 millimeter mercury is actually equal to 100.525 kilopascal, no? So we are going to add that in here. So 100.525 kilopascal plus 9.81 times 0.415 times 100 minus 1.3 divided by 1,000, and our answer here will be 104.59 kilopascal. So this is our final answer in here. So, tignan natin kung kapareho ba yan ng ating nambibin nila dito na answer, no? So, ang answer nila rito is 104.6 kilopascal and this is equal to our answer here. So, pag ni-round off natin to into a single decimal, so we have 104.6 which is equal dito, no? Now, we're going to convert this into PSIA. So, we have our PA is equal to 104.59 kilopascal times 101.325 kilopascal times 14.7 PSIA. So therefore, our PA is equal to 104.59 times 14.7 divided by 101.325. This is equal to 15.17 PSIA. And this is our final answer. So, tignan natin. 15.17 ba yung sagot dito sa taas? And yes, this is equal to the given here. So, therefore, tama yung naging answer natin sa problem na to. Okay, so we are now going to the next problem. Okay, so determine the pressure at A. So, at this point, in PSI gauge, due to the deflection of the mercury, which has specific gravity of 13.57 in the YouTube gauge shown in figure 2-8, which is this one. So, take note at ang pinahanap sa atin dito at ang mga given natin is in gauge pressure, no? So, therefore, yung reading natin ng manometer is already in gauge. So, we don't have to consider itong atmospheric pressure natin, no? Okay, so, again, katulad ng ginawa natin on previous problem, what can we do in order to get the pressure in A? Okay, we learned in our previous lecture and katulad ng ginawa natin sa previous problem, surface of the same liquid will have the same pressure, no? So that means if we cut this here, the pressure here is equal to the pressure here. In that case, the pressure here in B is equal to the pressure here in C, diba? So, we are going to write that here. The pressure in B is equal to the pressure in C. So, now we are going to take the pressure in B from the left side of our manometer and the pressure on C from the right side of our manometer, okay? Okay, so simulan natin yung ating B. So, paano natin makukuha yung pressure in B? First, we have the pressure on A. So, ito ang hinahanap natin. What's the pressure in A? Plus the pressure from here until here. So, we're going to consider now yung liquid natin, no? So, in here, our liquid is water. So, therefore, we have the density of water times the acceleration due to gravity. Now, everything is in English units, so we are going to use the English unit here. So, we'll have the gravitational conversion factor here, no, GC, and then our height of water. Okay? And this is equal to the pressure in C. So, how do we get the pressure on C? So, we have pressure on D plus, okay, so the pressure on D plus our liquid here is mercury having a specific gravity of 13.57. So, our fluid here is mercury. So, we need here the density of mercury times the acceleration due to gravity times the height of the mercury, diba? So, that's our formula in here. However, katulad nung sinabi ko kanina, gauge pressure tayo rito. So, we don't need the atmospheric pressure from here. So, this is equal to 0. Okay, so substitute na natin yung ating mga value. Pressure on A plus the density of water, which is 62.4 pound mass per cubic feet. Okay, naka-English unit tayo, no? And then our G over GC. So, our G is equal to 32.174 feet per second squared over 32.174 pound mass feet over pound force second squared. And then, ang ating height from point A to point B, ano yung height natin? We have 12 feet minus 10 feet, no? So, 12 minus 10, and this is in foot, okay? So, our unit here will be, pound mass will be cancelled out. Our second squared will be cancelled out. So, we have here, in our numerator, we have feet and feet. In our denominator, we have cubic feet and feet. So, therefore, our unit here will be pound force per feet squared, no? So, we have to take note of our unit. So, moving on, this is equal to, our PD is equal to 0. So, the density of mercury, we will have the specific gravity, which is 13.57, times the density of water, which is 62.4 pound mass per feet cube, times 32.174 feet second squared over 32.174 pound mass feet per pound force second squared, and then multiply it to the height. What is the height of our mercury? We have 12.65 minus 10 feet, which is here 10, and this is in foot. Okay, so now we're going to calculate, no? Alam na natin ang ating unit will be in pound force over feet squared. Okay, so now we'll have here pressure of A plus, so 62.4 times 12 minus 10, this is equal to 124.8. Okay, pound force per feet squared. And this is equal to 13.57 times 62.4 times 12.65 minus 10. And this is equal to 2,248.896 pound force per feet squared, no? So, isolating ang ating PA para makuha natin yung value niya, we have PA is equal to 2,248.896 minus 124.8. So, this is equal to 2,124.096 pound force per feet squared, no? But, we'll have to express this in PSI. Okay, so dahil ang pinahanap sa atin dito is in PSI. So, we'll convert this into PSI. So, we have PA is equal to 2,124.096 pound force per feet squared times. In 1 foot, we have 12 inches and this will be squared. So, our pressure in A is equal to 2,124.096 divided by 12 squared, and this is equal to 14.75 PSI, and this is in gauge pressure, no? Well, this is our final answer for this problem. And now, guys, let's go to the final question here. Okay, so we have here a manometer which is attached to a tank containing 3 different fluids. So, meron tayong air, meron tayong oil, and meron tayong water. As shown on figure 2-9. Find the difference in elevation of mercury column in the manometer. Okay? So, again, we know that to get the pressure using our manometer, we know that the pressure on A is equal to the pressure on B, di ba? So, we are going to use that on this problem. PA is equal to PB. Okay, so ang pinahanap sa atin dito is itong height ng ating Y. So, yung reading ng ating manometer. Okay, so, we need first to get the pressure A, no? So, in order to get that, we'll have the pressure of our air here, which is equal to the pressure of air, plus the pressure due to the oil. So to get that, we have the density of the oil, the acceleration due to gravity, and the height, okay, of the oil. Plus, now we have water here. So we have the density of water, acceleration due to gravity, and height of the water. And this is equal to PB. So what is our PB? Our PB is equal to the density of the mercury times G and height of the mercury, no? And we need to take note that ang hinahanap natin dito is yung height ng mercury, no? And in our formula, we have rho GH. Yung H natin is yung height ng mercury, but in here, it is referred as Y. So better, palitan na natin to ng Y para we will be using kung ano man yung ginagamit ng ating problem, no? Kung ano man ang symbol or variable na ginagamit niya. So in here, we have Y. Okay, so now we will substitute our values. The pressure of A is equal to 30 kilopascal. Okay, so take note na natin. We are in kilopascal. Kailangan lahat yan naka-kilopascal, lahat ng ating term para may add natin siya dito. So, plus the density of our oil. So, we have the specific gravity which is 0.82. Okay, times the density of water which is 1,000 kilogram per cubic meter. And then we will multiply to our G the acceleration due to gravity which is 9.81 meter per second squared. And then ang height ng oil which is 5 minus 2 meters which is equal to 3 meters. So ano yung unit natin dito? No? We have kilogram meter per second squared which is Newton. Then meters divided by cubic meter which is square meter. So our unit is in Newton per square meter which is Pascal. So we have to convert that to kilopascal para may add natin siya. No? So we need consistency of units. So therefore, we will be multiplying this to 1 kilopascal over 1,000 Newton per square meter. Then plus density of water which is 1,000 kilogram per cubic meter times the acceleration due to gravity, and then times yung height ng water. So what is the height of water in this case? We have 0 to 2 meters. So this is automatically equal to 2 meters, right? But our water extends until our point here. So this is equal to 1 meter. So therefore, our height of water is from this point until this point, which is equal to 2 plus 1 meter. So this is equal to 3 meters. Okay? And then we will convert this into kilopascal. No? So we have now here the left side of our equation. Now, this is equal to PB, which is rho GY of our mercury. So we need to get the density of mercury. So we have the specific gravity, which is 13.6 times the density of water, 1,000 kilogram per cubic meter, times the acceleration due to gravity, which is 9.81 meter per second squared. And then our Y, okay, ito yung hinahanap natin. And then we will convert this into kilopascal. So 1,000 Newton per square meter is 1 kilopascal. So now we have a consistent dimension. Everything is expressed in kilopascal. So now let us solve this further. So we have 30 kilopascal. So rewrite muna natin. We have 30 kilopascal plus 0.82 times 1,000 times 9.81 times 3 divided by 1,000 is equal to 24.1326 kilopascal. Then plus 1,000 times 9.81 times 3, and this is equal to 29.43 kilopascal. This is equal to 13.6 times 1,000 times 9.81 divided by 1,000. This is equal to 133 0.416 kilopascal times Y. Okay, so yan ang hinahanap natin, ang ating Y. Okay, now isolating Y, we will have here 30 plus 24.1326 plus 29.43 divided by 133.416, and this is equal to 0.626 meters. And this is, guys, our final answer for this problem. Well, that's it for now, guys, and thank you for watching. We are inviting you to register sa www.engineers.org. It is a community of Filipino engineers, engineering students, and STEM students. Thank you very much and have a nice day.